All right, so I know it's going to be painful. You just come back from lunch. So I'm going to try to be entertain you. And if I see you sleeping, then it's going to be a disaster for me. And I need your help. I need your energy. Otherwise, it's going to be boring for me to just talk in front of you. So I will try to request for your help during that presentation. All right, so welcome to the Kubernetes Guardians, a deep dive into security Avengers. My name is Henrik Rexed. I'm a cloud native advocate and a CNCF ambassador since a year now. So I work at Dynatrace on topics related to Kubernetes, open telemetry, security aspects as well. I'm pretty much an observability geek, to be honest. I love observability. I love to get data and ingest data and try to figure out what we can do with it. My background is performance engineering. I've been spending all my career breaking, testing, tuning. I think performance engineering is an amazing practice because at the end it's a way of learning and discovering so much new architecture and how to tune them. So I think if anyone wants to learn things, check out performance engineering. Performance engineering is still in my heart, so that's why I try to do content when I have the time on a YouTube channel called PerfByte. And if you want to learn French and performance engineering, I also launched the PerfByte Français channel with a French-speaking language. 3 years ago, I started a YouTube channel called Is It Observable? Yeah, you have it in a name dedicated to observability. So check it out, it's out there. And most of the stuff that I'm going to present today, they are already deep dive contents about each individual solution. So if you want to get more deeper on the solution, check out the channel. So let's start. Small disclaimer. So I did a benchmark. I had to run tests to figure out who is the best solution out there in the market. So I can guarantee that I was very nice with each individual solution. So I didn't harm any Spartans, no eagles, no bees. Everything has been very nice and gentle with those solutions. And they didn't break, in fact, so that's a good sign. The intention of this presentation is not to blame any solution. In the opposite, I have opened issues in each individual project to share my feedback. And this session is more about helping you to figure out what is the best solution out there that could fit to my project. So let me present the 4 superheroes of this presentation. So we have on the top right, we have Falco, the eagle. It's the oldest solution in the CNCF landscape. You see that by his history, maybe the design has a major difference compared to the other solutions. Then we have the bee, so Tetragon, pretty much aligned with ebpf. Very interesting behind the scene. Falco is this dig behind the project, behind the open source project. But for Tetragon, the project behind is Cilium, and it's going to be isoviolent, and it's going to be Cisco, because isoviolent is a Cisco company now. KubeArmor, new fresh solutions in the CNCF landscape. Very interesting. It handles security in a different way. We'll see. We'll touch base on this later on. And then I added, initially this presentation was adding Tracy, but Tracy is not part of the CNCF landscape. So I have changed that presentation to include KubeScape, because KubeScape is now on the CNCF landscape. It's not specialized in runtime threat detections. It covers everything. It's insane. But it has a runtime threat detection. So I said, oh, let's add that into the benchmark. And behind this project, it's Armo, the company specializes in security. So, and you'll see I selected this wizard because you see it's quite magical. All right, so what are you going to learn if you stay with me? I hope you're going to stay with me, because otherwise I didn't do a great job. I will first remind what do we expect from a security agent, because obviously there are a couple of core features that we need, and we're going to touch base on them. And then we're going to run through a comparison. The first by what are the components that we need in those environments to run those solutions? What is the design experience? Because at the end, we're going to define policies. And you'll see that depending on the solution, the design experience will be kind of difficult. And then we have of course, the security. I won't touch base so much on the security side because to respect the time that we have left. And of course, those solutions will extend some observability data. So we'll cover the observability picture that those solutions brings to our solution. And we'll cover, of course, the benchmarking results to see if those solutions are introducing latency to our applications or not. And last, a small recommendation at the end of this presentation. All right, so first let me introduce the power, because to be a superhero, in the runtime threat detections, you need obviously superpowers. And the superpowers are very simple. I'll need first, for those who never heard about runtime agents, the purpose of them is a bit like a security camera. So you have a camera sitting in the hotel or in an office. The camera at the end, as you know, is here to detect suspicious people or suspicious events in the building. It's the same thing with those solutions. It's going to be a camera that you're sitting on the cluster, and it's here to detect any suspicious events happening on a cluster, any process spawned or file access that is not supposed to happen. And to be able to achieve this, you need powers, and the powers will be first to be able to capture, because if you don't capture, then no way to react. You need obviously specific components to be able to run those solutions. Those solutions, we need to make sure that they are reliable, so we need to have some observability data out of that. There's a security posture, so they need to react on things. And last, having a security solution that slows down everything doesn't make sense, so there needs to be also performant. All right, so now let's start with the first power, and now for each individual title, I need your help. So when you see this title, I want you to name the title. So 1, 2, 3, component. Oh, come on, are you tired, guys? I don't get it. So 1, 2, 3. That's just much better. So I hope that the next section you will be more reactive, all right? So let's go. So the components. As you may expect, to be able to detect something in the cluster, we need to something smart as a technology that will detect any processes, file access, anything. And the best thing in the market for that is going to be ebpf. So what as a requirement for those solutions is, of course, every solution will have a daemon set with an ebpf programs that will be deployed in each individual node. So then all those process details and everything will be captured through that. So that's going to be one of the major requirements. So let's see. Falco has, when you deploy it, you will find this daemon set, as expected, no surprise. And then you have a Falco server. It's not an operator, it's a Falco server. And then you'll see that there's an optional component that we will probably install later on for the observability perspective. It's going to be Falco Sidekick. Then we have Tetragon. Tetragon, similar, we still have our daemon set with ebpf probes. We will have an operator, meaning that if you have an operator, if you listen to the talk that was happening this morning, you will have custom CRDs, custom resource definitions, that will allow us to define our policies. And then we have KubeArmor, same thing, a daemon set. And here you start to see, whoa, there's a lot of components here. This was my first reaction as well when I looked at the solution to us. So we have an operator, of course, with a lot of CRDs, more CRDs than Tetragon. And then we have two deployments. The relay server, in one hand, that will be used mainly for observability perspective. And then there's a controller. And honestly, I have no clue what it does. So if someone has the answer, let me know, because I will be very interested to see the purpose of that component. Then we have KubeScape, and KubeScape can say, wow, there's a lot of deployment. Yes, there are a lot of deployments, but remember, they are not doing only runtime threat detections. They are doing way, way, way more. So we have the agent that do runtime threat detections, networking policies, configurations. It has a KubeScape, the component that would do security posture management. They have kubevul to detect any vulnerability on the cluster, and they have a storage solutions to store all the details. And then they have lots of CRDs, because at the end, every scan, every things detected will be stored into the CRD, so you can just do a describe to get all the scoring, the details, and everything. So in terms of component, there's no clear winner. They have the components that we expect. I would say that there are, of course, solutions that are more on the right side, on the left side for you, that are lighter than the others. Now, I hope that next one will be better, honestly. So capture and filter. So what do we need to do that? We need, obviously, if a hacker take control on our container, there was a session this morning on Podscape. We are going to try to install things, so new processes, reach out to access files to get some tokens, be able to scan the networks to identify what is running in our cluster, change privileges. So we need to be able to capture those things. So capturing is great, but capturing an event without any details doesn't make sense. So we need to, of course, to add, in top of that, the process details, the user who has run or which group has run this process, the cumulative metadata, which container, which pod, which namespace, the file details, which file is been attached or modified, and potentially the syscall behind the scenes. for those solutions, having details is great, but you will see that having predefined rules will be essentials, because at the end, I'm not a kernel expert. If you are a kernel expert, then great. But usually when you have to define those predefined rules, it's quite annoying. So if you can have defined rules, that's a plus for sure compared to for the solutions. And last, it's part of the security. So observing things and not able to react is quite frustrating. So having the options to block this when the process is spawned is obviously more than required. All right, so Falco. So first, Falco, for those who never heard, it's not a security runtime agent. It's a rule-based engine. It's a server that just checks rules and say, yes, it matched the rules. That's the only thing he does. You say, what? Yes, it is. At the end, we can build our own SDK to say, oh, let's say I'm gonna create a plugin that will check my emails and then send it to the Falco server and create a rule on Falco server says, every time I have this title of an email, send me an event. That's what Falco is able to do. But yes, it does security. Why? Because when you deploy it by default, you get out of the box a kernel agent. And that kernel agent, of course, is the ebpf agent we talked about, that will basically collect process details, send it to the kernel, to the Falco server, and then if it matches one of the rules, it will emit an event, a log, telling us that there's something wrong happening. So by default, those agents captures all the details that we need. So that's why it's matched into our requirements. In terms of the event produced, so the log, there's a lot of details. And the problem is that it's not structured. And you will see why it's not structured. Because at the end, Falco has a syntax to create your rule. So when Falco starts, it loads a global file with all the rules predefined by Falco, which is fantastic. And you can modify and add your custom rules. So yeah, they have a specific syntax. And you can see here, does it work? Yes. There's an output here where you can define what will be the format of your message. So which means it depends on who created the rule. So there's no standardizing. So you will see later on the observability side, it has a disadvantage of parsing the log is kind of a nightmare, to be honest. That's one of the problems. The only downsides of this is also if you need to change a rule, then you need to stop the Falco server, modify the rule, and then restart the Falco server. So that's, I would say, compared to the other solution, is the major difference. Tetragon is based on ebpf at 100%, I mean like the others, but you will see why I'm saying this. When you deploy Tetragon, there's no policies deployed. The only thing he will produce in terms of events is letting you know that every process has, whatever process has started and whatever process has ended. So you will have those details. And then if you want, you can deploy policies, and those policies will produce more logs related to the policy that you have. Of course, if one of the policies match, you will have an event produced in the Falco logs. The way you attach, so the event produced here is that you get a lot of details. You have the process details, the process itself, and then you have the parent who called that process, and then of course details about Kubernetes and everything. The way you define policies, you need to attach it to similar to the logic of ebpf. So you will attach it to a kprob. So for those that doesn't know, it's a kernel function. A trace point, so a kernel event. uprob, so a user function, so you're running on a user space, and then LSM. So here is the tracing policies, and of course, we are all kernel experts. We know all the syscalls available. So here it's an example where I decided to create kprobs. You can see it's a kprob on the top. And then I match TCP connect. And of course, I know TCP connects the arguments and the types of the arguments, which is very important because at the end, if you define the right type, so here it's a socket, Tetragon will see the process and will deserialize the argument number 0, which is a socket, and then I will have the detail of the socket, which is great because at the end, when I will do my filtering rules to say only match that IP address or that communications, and that will be an event. So I don't know for you, but I don't know all the C code of each functions, so you will have to search for it and make sure that that function exists in your kernel as well. So I think the user experience is a bit a nightmare for those who are not a kernel experts. But at the end, if you understand the logic and what you can achieve, it's super powerful. So you can use it to do more than just security. You can do extended observability, but be attention, you will see in the performance aspects that it will put pressure on your kernels. Of course, out of Tetragon, you have the ability to react, and only on the way you're going to react, you can do crazy stuff. I mean, it's not just blocking. You can do many, many, many things. KubeArmor, when you install it, it doesn't do anything. That is quite frustrating. It will only do things and produce things if you deploy a policy. So you will have to deploy policies. And if you want to have events produced, because it's an operator and it's designed in a very smart way, you can add annotations to your namespace or add annotations to the workload, and then it will produce specific events related to the objects that you have put the annotations. And you can say, ask KubeArmor to produce events about processes, file, network, ebpf, so there's different options. Compared to the others, the event produce is super structured. Nothing's changed. So you will see that from the observer perspective, it's going to be very simple to parse the logs. And the operator also has a very smart way where you can also create a global rule, and then you can create an exception. So you can write an annotation to a namespace, say, oh, for this specific namespace, please block it. So you can basically have a different way of reacting, which I think is quite nice as well. In terms of policies, they have policies for the cluster, policies for the namespace and the deployment, and policies for the host. Maybe having one CRD will be good, but they have 3 CRDs. The way you configure it, it's very difficult. I mean, in a sense where you don't know how KubeArmor has captured the event. So that's why before you do anything, enable the events so you have an example. Then once you have the event, then you can start designing your rule. Because again, KubeArmor doesn't come with predefined rules, so you will have to build your own rules. And of course, when you build a rule, you can say the tag that you want to have, the message that you want to have, various type of actions. And similar to Tetragon, it's able to block any suspicious things, so you can have the options to block as well. KubeScape in that sense for runtime threat detections, like I said, it doesn't do only runtime threat detections. It's very smart. So when you deploy, it has a component called node agent, which has the ebpf row. It starts to be a learning phase. And the learning phase basically says, oh, this application used this process, this capabilities, this file. It lists everything. So then you can still go to that CRD, modify if you don't agree. And then every whatever seconds or minutes, he rescans and look at the differences. Oh, this app has a new process. That sounds strange. So I think that approach is I really like that approach. And it brings less overwrites into the cluster. It also have just out of the profile of the application, it can scan for malware, and it can also detect well-known suspicious security events. So in that sense, I think KubeScape is great. And if you, by default, it enables all the rules, so you have predefined rules enabled, and then you can still modify and say, okay, I don't want to have that rule. You can disable it, and it's quite easy to do it. So you cannot customize it. You can disable predefined rules, but it's quite smart in that sense. So to summarize on that, I think there's only, just for blocking, I would say there's only KubeArmor and Tetragon that can achieve it. There's only Falco and KubeScape that has predefined rules. In terms of customization, I think Falco, because it has its SDK, has the options. And Tetragon, it doesn't have SDK, but if you understand the power of what you can achieve with trace points and kprob, you can customize, you can do whatever you want. So now, oh, great, thank you. Our observability. So what do you expect for this? By nature, those solutions, they're going to extend your observability because they will produce events and attach it to your workload. So by nature, those solutions are indirectly related to observability. But to be able to observe, you need to be able to, like I said, it's going to emit something in the logs. So be able to parse the logs in an easy way is going to be a must. And then the fields exposed, you will see they are very heavy and a lot of fields will be involved. So having the options to customize to say, I only need those fields and the rest I don't care, that is great as an options. Be able to limit as well, because you will see that if you have one event happening every 10 milliseconds, then you open the STD out, yeah, you will have a lot of logs. So being able to turn on throttling, that is a must for those solutions. And last, those solutions are crucial because at the end, if they're not running, then we have no security camera running anymore. So having a health metrics to see if our policies are running, if the operator is running, I think it's kind of a must. So starting with Falco. So Falco, it emits the events not on the agents, but on the server. So collecting it, you can use the OpenTree collector if you want, but you'll see that parsing the logs will start to be complicated because you have so many different options of parsing it depending on the rule. So that's why Falco Sidekick come crucial. And Falco Sidekick will take the log, produce it in a nice way, and it also has an OpenTree log exporter, so then you could send it directly to your backend. Falco has also a Prometheus exporter, so you have all the details about the rules running, failing, and also, of course, the actual health of the actual server. So you get everything you need. Falco here, thumbs up, pretty good. Tetragon, it will emit the events on the agent side, so you will have to parse it. The logs are huge, usually so huge that most of the observability solutions are cropping the logs. So you will have to configure Tetragon to reduce the number of fields. So you have an option to do that. And you can also throttle, you have an option to throttle the actual events. In terms of Prometheus exporters, it has two of them, one on the agent side to see which policies are running and failing, and one on the operator side. So it has tons of metrics for that. I think well done, the Tetragon team. KubeArmor, well, KubeArmor only produce no logs on the agent side, and this is where relay server comes in the picture. So at the end, the relay server is pulling out the events from their own protocol back to the relay server and then emits logs from there. So if you want to collect the events, you will have to read it from the relay server. So that's a bit strange way. Parsing the logs is very easy because it's very standardized, so that's an advantage. And one thing that the KubeArmor project did, and I don't know why they're not maintaining it, they build a collector receiver to read directly from the agent. And I thought that was great, but it has not been maintained since the collector 096, which is a pain because it would be great to have it compatible with the newer release of the collector. And otherwise, in terms of observability, it doesn't provide you anything. You don't know how it works, so you have to cross the fingers. I know that for our OpenTelemetry issue, I know that you're working on an OpenTelemetry metric exporter on their operator, so it should be out there soon. KubeScape by nature, and it's been designed under OpenTelemetry, so every component in the KubeScape is emitting traces, logs, and metrics. But if you look at it, oh shit, I need to speed up. If you look at it, if you look at it deeply, it's pretty much interesting for maintainers. And for end user like us, you say, okay, what should I do about it? So that's why you were probably gonna rely on the Prometheus exporter on the node agents that sends you a lot of details about the logs, the runtime threat detections and more. And otherwise you have logs emitted through the node agents that give you all the runtime problems, and you have all the details that you need. And otherwise, like I said, all the scans and vulnerability network suggestions, they are available as a CRD. And in the collector, there's a receiver called Kubernetes Object Receiver, where you can read those CRDs and then emit some logs, so you can get all those details very easily. As a summary, I would say every solution is pretty great. The only one that could be improved is KubeArmor, because you don't have no metrics on the health of the actual solutions. But that should change in the future. Oh, yeah. Oh, you're getting tired, I guess. I am boring. So thank you. I don't know if I'm going to continue the presentation then. Okay, so what I wanted to measure with the performance side, I wanted to measure the latency that those runtime threat detections are adding to our applications. And then the other side is the resources. So the CPU that is being consumed into the cluster. And one thing important, they rely on ebpf. So they will probably consume not so much resources on the user space, but most on the kernel space. So we're going to measure how much ebpf, how heavy the ebpf programs are in our cluster. So for that, to achieve this, I was deploying Falco with the rules, the default rules, KubeScape as well, default rules, and then I added a few policies on KubeArmor, a few policies on Tetragon to have a pretty much match on the behavior of each solutions. And then what I did to measure the latency, I did a test without the agent, a test with Falco, and then a test with Tetragon without policies, Tetragon with policies, and then KubeArmor, same thing. So I can tell you that I did too many tests on my end. And last, KubeScape, only one test with the default policies. In terms of architecture, so you have the QR code if you want to replay that on your environments and have a nice weekend. If you're during a rainy weekend and you want to do some fun, you can still scan the QR code and have fun. To do that, I used the OpenTur demo, of course, the OpenTur collector, and then I used two unsafe applications that are running some suspicious events, the Goat app and Guard. I have the actual security solutions, and I added Inspector Gadget to measure the ebpf time of those solutions. So let's see the results. I did constant load and load tests. Constant load, I'm just going to share the constant because I didn't see much things about the load test itself. But the constant load, the first reactions when you have no policies, except for Falco and KubeScape, we have 3 milliseconds, almost 4 milliseconds added by Falco, KubeScape 13.85, and then Tetragon 3.3 milliseconds, and KubeArmor 5 milliseconds. But again, keep in mind, KubeArmor is not doing anything. It's just there. And then in terms of resources, KubeScape is consuming the most on the user space, but keep in mind it's doing everything, not only runtime for detections. And on the CPU side, it's going to be Falco who is consuming most of the CPU. And then on the ebpf side, for now, it's KubeScape who is consuming the memory and the CPU on the kernel side. Now, if I start adding policies, I mean, Falco already had it, so it didn't change anything on the latency. KubeScape, same thing, because it already had the policies involved. So Tetragon, suddenly when you add those policies, it's pretty much aligned with what the numbers we had with KubeScape. And Tetragon as well. So you can see, when I start to add ebpf, I start to have some differences. And then in terms of memory consumption, we still have KubeScape because it does so much things. And then you can see that now Falco is still the biggest consumer in the user space. But if you look at the kernel perspective, now it's Tetragon who's consuming the most after KubeScape. And then on the memory side on ebpf, it's KubeScape, and then afterward it's Falco. Now, if I turn on all the events, because remember, you can add more events, and this is only true for KubeArmor. You can see that KubeArmor jumped to 36 milliseconds. So beware of how much events you're producing, because it's going to have an impact. And then from the result perspective, you can see that now suddenly it's now the usage on the ebpf side of KubeArmor has erased because of obviously it does more things. So I have no major conclusion. I would say that Falco is pretty much amazing in terms of latency. KubeScape compared to the others, it's quite aligned. In terms of CPU, the best I would think, the user space is very difficult to take conclusion, but from the ebpf side, Falco CPU is quite honest, but you see the difference is that instead of consuming the kernel, it consumes in the user space. So you go on one end or the other. So conclusion, I would say, yeah, there's a lot of things. Yes. From my perspective, I love KubeScape because at the end, from a user perspective, I just have to deploy it, turn on, boom, I got everything. All the security requirements here, and it has all the observability. So I think KubeScape is doing an amazing job on that. But then, in terms of customizations, I was impressed by Tetragon because at the end, it provides the right observability, and it doesn't put too much latency in some of our applications. So if you are more like a kernel user, then Tetragon will be your best friend. If you're not a kernel user, then KubeScape will be an amazing solution. Like I said, small teaser to the Is It Observable channel, QR code here. All those is available on the channel. If you love the content, love it. If you hate the content, hate it, but let me know so that I can improve the content. And otherwise, if you have any questions, I will be very excited to answer your questions.